So let's start with a quick poll question. Do you have data such as documents or pictures that you want to organize into groups? All right. So let's start my topic. So I want to introduce our brand new machine learning library bundle, KMeans Bundle, today. So KMeans Bundle can be a very helpful tool to automatically find a cluster or groups in your data. KMeans itself is an unsupervised machine learning algorithm, which means that you don't need to know the previous knowledge to find the groups in your data. The KMeans on HPCC systems is especially designed to be a highly scalable, parallelized version of the classic KMeans. So that means, so you have small data or big data, it doesn't really matter. You can use the KMeans bundle on HPCC systems without worrying too much. So KMeans is the most popular clustering method. We can find the groups and the classes in the data very simply by run KMeans on the sample set. As we see in the left hand, that's a sample set, and we run KMeans on the sample. On the right hand is the results, and it automatically tell you there are groups and which sample belong to which cluster or the group. So KMeans, because it's a very popular clustering method and it's simply used in different areas in scientific and in the industrial field. For example, here is common practice using KMeans to find the cluster customer segmentations, such as if you want to find like new customers or inactive customers, loyal customers or high value customers, you can run KMeans on the customer sample set and find the answers. Another example here is we're using KMeans to segmentation the image. As we see in the picture in the middle, we use KMeans automatically find the different areas in one picture. We find the grass, the sky, the cloud, even the riverband. Another area that has intensely using KMeans is the in the medical area. We're using KMeans clustering gene expressions. So it helps the medical researchers find the genes sharing the same common traits. With all this introduction, let's go deeper to see how KMeans works. The first step is to initialize the K-centroids. And here we simply have one small example using K equal to 2. So I randomly draw two centroids here. The red one is central 1, the blue one is central 2. And the green triangle are the samples we're trying to cluster using KMeans. And then the next step is we calculating the pairwise distances between the centroids and the samples. So here we have 2 centroids and 10 samples. So totally we have to calculate 20 pairwise distances. With the distances in mind, the next step, choose the closest sample to each centroid and use those samples to take the new mean of the samples as a new position for the centroid. As seen in the picture, the red centroid, the centroid 1, dragged by the closest samples from the top right to a little bit lower left. And the blue centroid, the closest sample to the blue centroid, dragging the centroid from the bottom right to a little bit upper left. So we can repeat in the last 2 steps until KMeans converge. So in our simple example here, KMeans only need 1 iteration. It already converged here. But what if we have K equal to 3 in the same sample? When K-means have different K or the number of centroids, it have different results. That's usually the case. So when we're experimenting with different Ks, see what the results can be different from each other. And here, the result for 1K equal to 3 is like this. It's different from 1K equal to 2. So here is one dynamic picture. I want to show you how K-means dynamically changing the centroids along each iteration. With all this change, when the centroids don't change the centroid position anymore, or the centroid movement within the threshold of the tolerance, then K-means model gonna stop the iteration. Okay, so we now know how K-means works. Then let's see how to use K-means in our HPCC systems to automatically cluster your data. The first step is simply just import K-means bundle, and definitely, first of all, download the K-means bundle and install on your machine, and then simply import the K-means bundle using the import function, and then following the K-means as a bundle name, and then you can use the KM as a function to short name your bundle K-means to KM. And next step is train the model. The training process is very simple, just using the code here, copy into your ESL IDE, and then, or any like a VS Code, other ESL IDE you want to use, fit into the parameters here. So here I want to explaining the model parameters, such as the sample set and the centroid set. So they're either to understand the sample set or the sample you want to cluster, and the centroid set is the centroid you initialize for K-means. But the requirement here is they have to be in the numerical field type. So those are the type we defined for every machine learning bundle as a common entry. So the details for the numerical field you can find in the ML core bundle type model. And the next parameter is the maximum iteration. The max iterations means the maximum number of iterations K-means can run in your program. So usually sometimes we have K-means like running for like days, or based on your data or your the features. So sometimes in real practice, we control the iteration to converge in like a 30 or 100 based on your needs to control runtime. And the last one is the tolerance. The tolerance means the thresholds. For example, the centroids are moving from each iteration to the other one. And in this iteration, the movement can be very small, like 0.00001, and in sometimes we call it converge. So those are the only 4 things you have to keep in mind when you train the model. The last step is optional if you want to predict for new samples. For example, you have K-means in your hand, you have the model already trained, and now you want to see what the other samples in the same data, what they gonna belong to. Then you use the predict function here, input the model you have, and then the new sample set you have. And here, same thing, the new sample has to be in the numerical field format. And then the result's gonna tell you all the group labels for each new sample. Okay, simple and easy. That's the K-means bundle in HPCC systems. Let's see the last poll question. Will this K-means bundle be helpful for you to explore your data in the future? Thank you for your listening. And if you have any questions for K-means or using K-means in your projects, feel free to contact me. Thank you.
All right. Lili, it looks like we have several questions already coming in from the audience. We have a very active audience today, it looks like. So while you take a peek at those questions, I'm going to go back to your very first poll question, which was, do you have data such as documents or pictures that you want to organize into groups? And it looks like 100% of the people that responded said yes. So I'm hoping that people have learned from this. And I'd also like to mention that Lili has a blog on this topic out on the HPCC Systems website. Just go to the blog and you can click on Lili's name, and this blog should come up so you can get more information there. All right, Lili, are you ready for your questions?
Yes.
All right. So the first question is there documentation or a guide available on where to learn more about KMeans?
Yes, sure we have. So we have a KMeans Bundle's detailed documentation online, and which is lovely attached by our team here, by Jessica, I think. I think the audience can see here, we have KMeans tutorial. That's the KMeans detailed tutorial with specific data online. And the KMeans Bundle, I think that's the documentation. And we also have the machine learning library in general introduction to our machine learning libraries, including KMeans. So feel free to go there and explore more about SL KMeans. And the second question is it possible to have a training session to use machine learning algorithms such as KMeans? Yes, sure. Feel free to shoot me an email if you want to have a training session to learn ECL or HPCC systems or any machine learning algorithms in our platform. I'm more than happy to go there and give a training session for sure.
All right. It looks like there's a ton of information available, and if people have questions, they can reach out to you directly. Correct, Lili?
I'm sorry?
It looks like there's a lot of options for people to get more information, correct? And they can also reach out to you, so that's great.
Yeah, sure. Feel free to shoot me an email and let me know, do you want to learn or have a training session in your school or in your office, in your company? I'm happy to do that.
Fantastic, fantastic. Okay. So do you have any future work planned regarding clustering algorithms and HPCC systems?
Yes, we do. We actually have a lot of clustering algorithms in mind to implementing in the near future. The recent one is the DBScan. It's another clustering algorithm commonly used in the density-based field. So we're trying to make it happen in near future. So I would like to introduce it to the wider audience when it's ready. And then some other question is, are there limitations on KMeans? Yes, so KMeans is usually it's a Euclidean space, defined space. So which means if the space is not really Euclidean distance defined space, then it's not usually helpful using KMeans. And also KMeans is the optimization function define that you cannot really draw any free shape for your cluster. So that's why we have the future work, the DBScan, which is a density-based clustering methods that are complementary to KMeans to clustering the free-shaped clusters.
So while you take a look at the questions, or if anyone has any additional questions, go ahead and send them in. And while you do that, I'm going to take a quick look at Lili's last poll question, which was, will this KMeans bundle be helpful to explore your data in the future? And 85% of the folks that answered said yes, so that's great. Hopefully that you've learned something from this talk, or at least you know how to reach out for more information. So that's great. Lili, it looks like we have another question that came in. And it is, what is the largest test set HPCC systems KMeans was tested on?
Yep, so the KMeans has been intensively tested on different sizes of data, like small data or big one. And normally we test on the normal range is hundreds of millions of records. And we tested on like hundreds of nodes of a cluster too. So we did a lot of jobs to test on big data. Yep.
All right, fantastic. Lili, thank you so much for coming today. We've had a lot of great interest in your presentation, great questions from the audience.
All right.
So thank you.
Thank you.